In our workshop, we have machines that build objects layer by layer, and we have lasers that burn designs onto surfaces. But this is subtractive manufacturing, the third pillar of a complete digital fabrication workshop. But what if you haven't tackled lasers yet and you're thinking about it? I'm going to suggest you consider a machine like this instead. And by the end of this video, you will know exactly why. Today, we are diving into my very first experience with a CNC router, the Acmer Ascarva 4S. The biggest question for me, and probably for many of you, will this technology become a core part of my project, or will it just be a one-off experiment? Will I stick with it or forget about it? The answer might just lie in these future plans. So, let's find out. I'm gerGO, and this is gerGO Print 3D, the YouTube channel where my little nephew Levi and I share all the adventures we have with our 3D printers, laser machines, and now even a CNC router. Just like our earlier videos, this one has curated, translation-ready subtitles, chapter markers, and audio tracks in more than 20 languages, köztük most már magyarul is a saját hangomon, so ha akarsz kapcsolják. The origin story. This all started when our friends at Acmer reached out. They initially offered to send another 10-watt open frame diode laser for a review. Now, I've had good experiences with their Acmer P1 laser, which we also used in our Go set project. But I explained that for our family-oriented channel, we prefer enclosed devices for safety. I suggested either an enclosure or, throwing a bit of a curveball, a CNC machine, as I've been curious about them for a while. To my surprise and excitement, they agreed and offered the Ascarva 4S. They mentioned it was an enclosed model, which was confusing since I couldn't find any pictures of it with an enclosure online, but my curiosity had been piqued. I'd been looking at CNCs in the $500 to $1,000 range, so I was thrilled that Acmer was willing to trust me with one. The question is, was my excitement premature? Before we dive into building our first CNC, I want to give a huge shout out to PCBWay for sponsoring our channel. On a hobby machine like the 4S, our goal is to eventually tackle hardwoods and soft metals like aluminum. But what if your project needs something more? PCBWay's professional services can machine an incredible range of materials, from plastics like polycarbonate and nylon to serious industrial metals like stainless steel, titanium, and even carbon fiber. For some projects, it's smarter and even cheaper to outsource than to buy expensive tools and raw materials, all the trial and error, and not to mention avoiding harmful fumes from certain plastics. It's amazing how affordable it can be to have a complex part professionally machined, and you can even consult with their experts. So before you invest a lot of time and money into a new process, be sure to check out the wide range of CNC services PCBWay offers using the link in the description. A major thank you again to PCBWay. Now let's see what's in that box. Unboxing and assembly, a beginner's deep dive. I'm going to go into unusual detail during this unboxing and assembly. There are two reasons for this. First, since this is my first CNC, I'm assuming it might be the first for many of you watching too. Second, there is surprisingly little information about this specific model online. As I was waiting for it to arrive, I would have loved a detailed video to set my expectations. So I'm creating the resource I wish I had. And let's be honest, if there's a way to assemble something wrong, I'm usually the first person to find it, so you're in good hands. Laying all the parts out on the table, we get a good look at what we are working with. We have the aluminum extrusions for the frame, a full assembled X-axis gantry, the two Y-axis modules, various connection plates, and clearly labeled bags of screws and tools. We also have a detachable touchscreen, some sample materials, and this hefty control box with the big red emergency stop button that we know well from our laser engravers. As a complete CNC novice, looking at all these pieces, I had no idea if this assembly would be a 30-minute sprint or a multi-hour marathon compared to the 3D printers and lasers we are used to. So let's make this interesting. Pause the video, head down to the comments and leave your best guess. How long do you think this whole assembly will take me? We'll see who gets closest. I started by following the manual, which I have to say is excellent. Very clear illustrations, good explanations and detailed steps. I began by building the base frame, then attaching the left Y-axis module with its drag chain and the attached controller box, followed by the right Y-axis module. And right there, as I attached those Y-axis modules to the base, I made my first mistake, though I wouldn't realize it for a few more steps. Here's the illustration from the manual, and here's my assembly. Can you spot the problem? I'll let you know in a second. But before we solve that puzzle, let's install the X-axis. This is the fully assembled gantry with the tool head already mounted. There was another little puzzle here. Where does this so-called isolation column go? The illustration had so little context, I had to play detective. The front right corner was blocked by the controller box, and the other two front corners already had these little physical bumpers to stop the gantry. And that left only one possible spot, the back left. With that figured out, the gantry snapped into place and was secured with 6 screws. Unlike some other build videos I've seen, I had no trouble installing the spoil boards. Just remember to place them nuts side down, otherwise the clamps won't sit flat and might pull the nuts out. It does require a lot of screws though. I'm so thankful for the new toolkit Otto sent over, especially this powerful drill. Now if you thought all these screws were a lot, that was just the warm-up. The last structural step seemed innocent enough. Just attach the baffle plate to the front. But, did you catch it? There are no screw holes for it on the front. They are at the back. Yes, 4 steps earlier, I had installed the base frame backwards. Luckily, I didn't have to backtrack completely. I could just lift the assembled gantry and flip the base around. Still, watch out for those 2 little holes when orienting the base. There's an impressive number of cables running from the control box to the tool head, but thankfully they all have different plugs, so even I couldn't mix them up. It looks a bit messy, but it adds to the seriousness of the device. It looks serious, but is it useful? One thing we can surely confirm, that it's not enclosed. Does it even work? Let's connect the touchscreen, which I love by the way. More 3D printers and lasers should come with a pendant like this. And we are ready to turn it on. All right, time to check our bets. For those of you who left guesses in the comments, let's see how you did. Even with filming and backtracking on my mistake, I was able to complete the entire assembly in just under an hour. Acmer did a really good job with the 4S. It truly is easy to put together. I'm confident that after watching me, you'll be able to do it in 30 minutes. If you end up building one, I'd love for you to come back to your comment and update it with your actual time and experience. First impressions and a faulty probe. Press the power button, nothing. Oh, you have to plug it in. Unlock the key, release the emergency stop button, and then press power. And it's alive, and it's roaring. This idle noise is on par with my SV08 Max, if you remember. Before I muzzled it, watch here how I did it. This cooling fan will definitely have to be replaced in a similar manner. But let's not let this spoil our first impression. This is a robust structure. The palm wheels travel smoothly in both directions, though the tool head will needed a tiny adjustment. If you don't know how, watch my earlier video on palm wheels. The huge work area and solid frame are in stark contrast to the tiny 70-watt spindle that comes with it. I'm going to call it the placeholder spindle. It really feels like this machine was designed to be upgraded. In fact, the controller box has a port clearly marked 500 watts, and right next to it there are other standard ports for expansions, like adding a laser module. But for now, this is the spindle we have, so this is what I'm testing. The included toolset consists of 10 identical pointy bits, which I've learned are called V-bits. I loaded one into the 1/8" ER11 collet and attempted to follow the steps to calibrate the Z height using the included electric probe. One of the two other reviews of the 4S mentioned this probe didn't work, and I had the same failure. The needle pressed deep into the aluminum surface, and I had to slam the emergency stop to save it from snapping. I guess you could say the probe had a point to make, a really sharp one that I clearly wasn't getting at first. After a few more attempts that resulted in the probe successfully stabbing the block but failing to register, it was time for a detour. Using my multimeter, I confirmed that touching the alligator clip to the probe block didn't close the electrical circuit. Eventually, I narrowed it down to a connection failure in the standard 3.5mm jack, which was easy enough to fix by soldering on a replacement from an old pair of headphones. With the repaired probe, the calibration finally completed successfully. However, I'm still not 100% sure how to utilize these settings, as the manual gets very, very vague when it gets to the software. The CNC software Wild West. And that vagueness was no accident. I soon discovered that the entire software situation around hobby CNC is the Wild West. We are incredibly spoiled in the 3D printing world with amazing free options like Orca Slicer. Even laser cutters are better off. The industry standard Lightburn is a paid tool, but it's affordable and excellent. For CNC, you generally need 3 separate programs: a CAD program to design, a CAM program to generate toolpaths, and a G-code sender to control the machine. I looked into an integrated option called Easel. It's a beginner-friendly online tool, but you'll outgrow it fast, and the pro features cost an arm and a leg. If you pay monthly, $288 plus tax a year. Be careful not to get too attached to this option. A good free cam option is Kirimoto, but it's not as easy to use and lacks some features like V-bit engraving, as far as I know. Fusion 360 is a powerful free alternative for both CAD and CAM, but it feels overwhelming for a basic machine like this. I really wish Lightburn would add CNC features to its existing GRBL capabilities. Seems like a logical next step. An open source feature complete tool like Orca Slicer for 3D printing could bring standardization and a wave of new users to this hobby, but I guess this is a classic chicken and egg problem. First Carves and discoveries. With a limited tool set and a weak spindle, I started with a few engraving jobs in easel. The sample project came out okay. I then clamped down a larger piece of softwood and tried engraving the channel name and the portrait with varying success. I used easel's default settings for birchwood, 762 millimeters per minute feed rate, at 228 millimeters per minute plunge rate, the max 8000 RPM spindle speed, and a 0.71 millimeter depth per pass. I found the most attractive results came from shallow 1 to 2 millimeter deep engravings. However, the stock V-bit isn't ideal for clearing out pocket areas. It took a very long 20 minutes to engrave this rather small logo. Then I noticed that proper V-bit support is tied to a pro feature trial in easel. which I'm not signing up for, so I tried a little hack. I configured the V-bit as a custom other bit with a tiny diameter, first 0.5 millimeter, then 0.2 millimeter. With the 0.2 millimeter setting, the time and quality were remarkably similar to the official V-bit toolpath, and the carving too came out almost identical. This makes easel a plausible free option for this kind of engraving, as I couldn't find a way to do it in Kirimoto. Maybe I will later. My last project was this slab of wood, which I painted green. I thought the color was appropriate since I'm still pretty green at this whole CNC thing myself. The shallow carving produced a fantastic looking light colored logo and gave me the excitement to plan for the future. Normally, I periodically vacuum the sawdust, but with this last project, I tested what would happen if I only cleaned up at the very end. I expected a lot more dust, but for this speed and material, it's not that bad. In the long term, I'll need a proper dust collection solution, so this naturally leads us to the upgrades this system needs. But before we get into upgrades, please upgrade this video with a click on the like button and upgrade your experience with gerGO Print 3D with another click on the subscribe button. I appreciate all your support. The upgrade path, unleashing potential. As it is, the Ascarva 4S has great potential, but out of the box, it feels more like a toy. I started by ordering 3 sets of bits from AliExpress. Flat end mills, ball nose mills, and a variety of V-bits. These all expand the machine's capabilities towards 3D carving, even with the 70-watt spindle, though it will still be extremely slow. Yes, I'm looking forward to improving my results bit by bit. And yes, that pun was fully intended. After just a few days with the CNC, I realized how satisfying it is to work with wood. And I've already acquired a taste for it. As a result, I started going down the rabbit hole of spindle upgrades. Acmer mentions a 500-watt option, but with no details. I found many 500-watt DC spindles on AliExpress, but also 800-watt, 1500, and 2200 AC spindles with inverters, which suggest much better quality and quieter operation. With a stronger spindle, we'll have the ability to work with a wider range of materials like hardwoods or even soft metals, perfect for making custom gifts, personalized home decor, metal parts for 3D printer mods, or even prototyping products for a small business, all without the burning, laser hazards, and toxic fumes, though dust still needs to be maintained. A CNC router like the Ascarva 4S truly adds the missing components to my desktop fabrication workshop. And yes, the TF card slot is flimsy and they could have included Wi-Fi, but the USB connection is reliable. The loud fan needs a fix, but it should be cheap and simple. The underside spindle is a placeholder and the broken probe was an easy repair. The lack of dust collection is standard at this price. The software situation is murky, but I found a path forward with free tools. Coming full circle, and what's next? To answer our initial question, is this a valuable addition to our workshop? Yes, it can be, and my plans are the proof. First, I'll explore the new possibilities with the bits I've ordered. While I wait, I work on a quieter cooling fan solution that might even include some 3D printed parts. Then, when the new spindle arrives, I make a detailed upgrade video on the installation and testing. And finally, with that power, a dust collection system will be a must. So that's another video and other 3D prints. Be sure to subscribe to see how this project develops. The Acmer Ascarva 4S offers exactly what you should expect in this category. A good, expandable foundation with standard GRBL control, serviceable components, and a well-documented assembly process that's easier than many competitors. For DIYers, woodworkers, or someone starting a small Etsy shop, it's a solid first choice for an entry-level CNC. It has a low investment cost, and as we've seen, it has a clear and affordable upgrade path to turn it into a real small business game changer. I hope this video adds even more value for new owners, and if you decide to become one, please consider using my links and coupon codes below to help support my work. And that brings us to a final key advantage. And the reason I'd even say it might be your luck if you haven't invested in a laser yet. A platform like the Ascarva 4S is modular. You can swap this entire spindle assembly for a powerful laser module in just a few minutes. This means you're not just getting a CNC, you're getting a massive 400 by 400 millimeter, no compromise laser engraver as well, all on the same frame. One device with no extra space needs, opening both worlds at once. But don't worry, my main focus remains on 3D printing. We have updates coming on how our SVO8 Max is printing ABS, a deep dive into Demon Clipper Essentials, a software updates, a new intriguing printer from FSON, and powerful lasers from Monport and Tuca. Oh, and I still need to tell you about our humidity-controlled printer room. Would you like to know how this 110 volt USA version Bamboo Lab H2S got to us and how we made it work in Europe? Click here to find out. Or see all the upgrades we've made to our largest printer in this playlist. All these to help us go print 3D. Thank you for watching another gerGO Print 3D video all the way to the end. Happy carving!